This rock looks worthless. So do the next 100. But somewhere in this river, gold may be hiding in the gravel. A sapphire may be buried under dirt, and a ruby may be rolling downstream, disguised as an ordinary red stone. And not every valuable discovery is gold or a gemstone. Some rocks carry something even more unusual, a clue to the history of the earth itself. The river has been sorting these clues for thousands of years. The question is, which ugly rock is hiding the secret? Number 10. Black sand and magnetite. The dark sand that can point toward gold. You wash away the gravel. The light sand disappears. And at the bottom of the pan, a dark, heavy layer remains. Black sand, often containing minerals such as magnetite and ilmenite. It is not gold, but the same natural sorting process that concentrates heavy black sand can also concentrate gold behind boulders, in cracks in bedrock, and along old river channels. A small amount of placer gold may be worth only a few dollars. A large natural nugget can be worth far more. So when the river leaves black sand behind, the real question is, what else was heavy enough to stay with it? Number 9. Garnet, the red pebble that becomes a trail. One red pebble may mean nothing, but then you find another, and another. Now the pattern matters. Garnet is durable enough to survive weathering and river transport. The surrounding rock breaks down, the garnet remains, and a concentration of garnets can sometimes point toward a source upstream. Common red garnet may sell for around $10 to $60 per carat. Fine varieties can reach hundreds of dollars per carat. Rare green garnets can reach hundreds to several $1,000s per carat. But the most important clue is not the price, it is repetition. One red stone may be random. A trail of them may be a map. Number 8. Sapphire, the blue gem hiding under dirt. A rough sapphire may not look like a sapphire. Clay can cover it. Iron staining can turn it brown. River transport can scratch and round it. Then you wash it. The dirt disappears. And suddenly, blue appears. Sapphire is corundum, one of the hardest natural minerals on Earth. That hardness helps it survive while softer minerals disappear. Commercial stones may be worth tens to hundreds of dollars per carat. Fine natural sapphires can reach thousands of dollars per carat. But color is only the beginning. Clarity, treatment, origin, and cutting potential matter too. So the question is, what was hiding beneath the surface? Number 7. Agate and chalcedony. The rock that changes when you cut it open. From the outside, this may look like an ordinary river stone. Then the saw cuts through it. Bands appear. Patterns emerge. Color fills the interior. Agate forms as silica-rich fluids deposit layer after layer inside cavities and fractures. The outside may look worthless. The inside may be the entire discovery. Common agate can be worth only a few dollars per carat equivalent. Fine material can reach tens of dollars per carat equivalent. Exceptional specimens may be worth far more as collector's pieces. So ask yourself, how many discoveries are hidden inside rocks nobody ever cuts open? Number 6. Jade, the green rock that refuses to break. A green river pebble could be almost anything. Serpentine, altered volcanic rock, a copper mineral, or jade. Jadeite and nephrite form in very different geological environments. But both can be exceptionally tough. That toughness allows jade to survive impacts that destroy softer rocks. Lower-grade material may be worth only a few dollars per carat. Fine jadeite can reach hundreds or thousands of dollars per carat. The rarest top-quality material can reach tens of thousands of dollars per carat. But color alone proves nothing. The question is not, is it green? It is, why did this green rock survive? Number 5. Gold and pyrite, the rock that looks like gold, A yellow flash in a riverbed and can create instant excitement, but pyrite, mica, and chalcopyrite can all fool the eye. Gold is different. It is extremely dense and malleable. It bends instead of simply shattering. But the surrounding geology may be even more important. Quartz veins, fractures, iron staining, sulfides, hydrothermal alteration. These can reveal the geological system that produced mineralization. A small piece of placer gold may be worth only a few dollars. A natural nugget may be worth far more. So ask yourself, did you find gold or the system that made it possible? Number 4. Zircon.
The tiny crystal that carries deep time. This crystal may be smaller than a grain of rice, but it can carry a story older than the landscape around it. Zircon can survive the destruction of the rocks that formed it. It can remain in sediment long after ancient mountains have disappeared. When zircon forms, uranium can enter its crystal structure. Over immense spans of time, that uranium slowly decays into lead. By measuring the relationship between them, scientists can estimate when the crystal formed. A tiny grain can reveal the age of ancient crust or geological events that left almost nothing visible today. Fine gem-quality zircon can reach hundreds of dollars per carat, but its greatest value may not be its price. It may be the history locked inside. Zircon is a clock. So ask yourself, how old is the oldest thing you have ever held? Number 3. Topaz. The crystal whose shape reveals how it grew. Among ordinary river gravel, a clear golden or pale blue crystal can suddenly stand out. It may look like glass, but unlike a broken piece of glass, a natural topaz crystal may preserve sharp geometric faces, flat surfaces, clean edges, and sometimes a distinct crystal termination. That shape is the first clue. Topaz is hard enough to survive transport from its original geological source into some alluvial environments. But a river can also damage it. Edges may become worn, the surface may be scratched, and dirt can hide the crystal's original form. So a prospector may first notice something simple, a heavy, unusually clear crystal with a shape that looks too organized to be ordinary glass. That is when the geology becomes fascinating. Inside the crystal, atoms are arranged in an ordered structure. That architecture influences the faces, edges, and terminations the crystal develops. The shape is not random. It is the visible result of how the crystal grew, layer by layer, atom by atom. Topaz can be colorless, yellow, orange, brown, pink, or blue. Treated blue topaz may sell for only a few dollars to tens of dollars per carat. Fine natural golden or sherry-colored topaz can reach tens to hundreds of dollars per carat. Rare natural imperial and pink topaz can reach hundreds to several $1,000s per carat. But in a river, the first question is not, how much is this worth? It is, why does this crystal have this shape? Zircon is a clock. Topaz is a blueprint. One records deep time, the other reveals how a crystal was built. So the next time a clear or golden crystal appears among ordinary river gravel, look closely at the geometry, because sometimes the shape itself is the first clue. Number 2. Ruby. The red stone that could be almost anything. A red pebble is exciting, but red is only a color. Garnet can be red. Spinel can be red. Ruby can be red. Rough ruby may be dark, fractured, opaque, or covered in weathering. Ruby is the red variety of corundum. Its exceptional hardness allows it to survive transport into alluvial deposits. Commercial quality ruby may be worth hundreds to several $1,000s per carat. Fine natural ruby can reach tens of thousands of dollars per carat. But a red pebble is not automatically ruby, and even a genuine ruby is not automatically valuable. Color creates excitement. Identification creates value. So, which red stone did you actually find? Number 1. River gravel. The ordinary rock that may be carrying the biggest clue. The most important discovery in a river may not be a single gemstone. It may be an ordinary piece of gravel, a dull stone, a heavy pebble, a dark fragment, something you could easily walk past. But look at what is around it. Black sand, red garnet, heavy crystals, quartz fragments, perhaps corundum. Individually, each clue may be weak. Together, they can reveal a geological story. The original source rock breaks down, durable minerals survive, water transports them, and natural traps concentrate them. Gold, sapphire, ruby, garnet, and other valuable minerals can all become concentrated under the right conditions. The valuable stone may not be where you find the first clue. It may be upstream. The river may be carrying evidence away from a source still hidden in the landscape. A change in gravel, a change in bedrock, a concentration of heavy minerals, a sudden increase in unusual crystals. Together, these clues can turn a river into a map. Because sometimes, the first valuable discovery is not the gemstone itself. It is the ordinary rock that tells you where to look next. And that may be the most valuable clue in the entire river. A river can make a valuable mineral look ordinary. Mud can hide it, transport can round it, and millions of ordinary stones can bury it. But the river also leaves evidence. Heavy minerals concentrate, durable crystals survive, soft rocks disappear, and the landscape records the journey. Most river rocks are ordinary. Most black sand contains no visible gold.
Most red stones are not rubies. The skill is not believing every rock is treasure. It is learning which rocks deserve another look. Because the stone in your hand may not be the discovery. It may be the message. A message from somewhere upstream, from a hidden source, a fractured mountain, an ancient geological system. And perhaps that source has been releasing valuable minerals into the river, one crystal at a time, for thousands or millions of years. So the next time you walk past a dull gray pebble, look again at its weight, its texture, its shape, the minerals around it, and the place where you found it. Because the most valuable rock in the river may be the one that does not look valuable at all. This is Pro Gems, and sometimes the earth does not hide its treasures. It simply hides them among ordinary things.